Hello friends, in this video we will discuss how to add more than two vectors numerically. Please make sure you watched part 1 to part 5, then go ahead with part 6. So here is the problem. It says John starts from his home and travels 5 meter at 30° north from the east and 2 meter towards east, then 7 meter at 20° west from south and 3 meter to the south to the school. So John traveled these distances from home to the school, and we have to compute how far he displaced from his home to school. So first of all, we will draw all the displacement vectors using head to tail method. We have already discussed head to tail method in vectors part 2. So first of all, he traveled 5 meter at 30° north. So it would look like this. This is home. This is first displacement. Then he displaces 2 meter towards east. Then he displaces 7 meter at 20° west from the south. That means from this point we will draw 20° west. So suppose this is our south, and so 20° from the south we have to move towards west like this. This one is the 20°, and he displaces around 7 meter like this. So D3 equals 7 meter, and then 3 meter towards south. So from this point 3 meters moving down like towards south. This D4 equals 3 meters. So this point would be the school or end point, and this point is home or the start point, and we have to find the displacement from home to school. So we have to find magnitude and direction of this displacement vector D. So to find this displacement vector D, we need to add all the given vectors D1, D2, D3 and D4. So D equals D1 plus D2 plus D3 plus D4. These all are vectors, so we need to use vector component method. So for that, step 1, we need to resolve each vector into horizontal and vertical components, or you can say X and Y components. So let's make a table for that. Here we will put X components and here Y components. So first of all, D1. So for D1, this is the X component, D1X, and this one would be the Y component, D1Y. D1X would equal D1 cos theta, and D1Y equals D1 sin theta. Just plug in values. D1 equals to 5 and theta equals to 30°. 5 sin 30°. So this will give us 4.33 meters, and this will give us 2.5 meters. So next we have to do the same thing for D2. You can see D2 is already a horizontal vector, so its vertical component or dy would be 0. So D2x would equal 2 meters and D2y would equals to 0. D2x would be positive because D2 is directing towards east direction, and east is a positive direction. Now let's take D3. So vertical component of D3 would be towards south. As you can see, D3 is directing southwest, so its vertical component D3y would be towards south, and horizontal component D3x would be towards west. So D3x and D3y both would be negative because west and south both are negative direction. So we have to put negative sign before the equation, and D3y equals D3 cos theta and D3x equals D3 sin theta. Here you can see y component has the cos and x component has sin. Why? You might remember we have discussed in vectors part 3 that the component adjacent to the angle would have cos. Like here D3y is adjacent to angle 20 degree, so it would have the cos and another component would have the sine. So D3y equals to D3 cos theta and D3x equals to D3 sine theta. So let's plug in values. So minus 7 sine 20 degree and this would be minus 7 cos 20 degree. So this will give us minus 2.394 meters and this will give us minus 6.578 meters. Now the last vector, which is D4, and it's directing towards south and it's a vertical vector, so its x component would be 0 while the y component D4y would be the negative 3 because south is the negative direction and vertical vector has the 3 meter magnitude, so minus 3 meters. We have x and y components of all the 4 vectors. Using these x and y components, we can find the x and y component of resultant vector D. So we can do dx equals to d1x plus d2x plus d3x plus d4x. We have to add all these values with sign. So 4.33 plus 2 minus 2.394 plus 0. This will give us 3.936 meters. Same way we can find the y component of resultant vector D, which is dy. So dy would equal d1y plus d2y plus d3y plus d4y. Keep in mind we have to add all the values with sign. If it has minus sign, then we have to subtract that value. So it would be like this: 2.5 plus 0 minus 6.578 minus 3. This will give us minus 7.078 meters. So now we have x and y component of resultant vector D. Let's take another page. So for the magnitude, we use the formula root dx to the whole square plus dy to the whole square. This will give us 8.098 meters. So this is the magnitude of displacement vector D. So John displays 8.098 meter from home to the school. Now we have to find in which direction. So for direction, we use tan inverse dy over dx, tan inverse minus 7.078 divided by 8.098. This gives us minus 41.15 degree. So you know our displacement vector was like this. So from positive x-axis, it is in the clockwise direction. This one would be 41.15 degree, our displacement. So John displaced 8.098 meter at 41.15 degree clockwise direction from the positive x-axis. That's the answer. I hope you understand this topic so far. In the next video, we will discuss how to subtract two vectors numerically. So stay tuned and study more. Don't forget to subscribe, share and likes for daily updates. Thank you.